10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REX, its 7-year mission to boldly go to the asteroid Bennu and back.
Lyrics look good. Hard-to-believe pump speeds and injector pressures are within family. SRB chamber pressures have plateaued, begun to ramp off.
During the voice of Marty Malinowski, the Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Marty 180, injector pressures look good.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REX has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle hydrates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30 seconds,
the
single solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily.
And you see the solid rocket booster jettison.
Separation looks good.
1 hour later, OSIRIS-REX separated from its Centaur upper stage rocket and drifted into space. It deployed its solar arrays to catch the rising sun and made a final pass over Australia before embarking on its outbound cruise to Bennu. After a year in orbit around the sun, OSIRIS-REX briefly returned to Earth in September 2017 for a gravity assist. The spacecraft passed within 18,000 kilometers of Antarctica, then turned its instrument deck toward home to capture images and spectra of the Earth and the Moon. The gravity assist bent the trajectory of OSIRIS-REX by 6 degrees, matching the orbital tilt of Bennu and sending the spacecraft on a path to catch its target. In August 2018, OSIRIS-REX began its approach phase. Its long-range camera captured the first visible light images of Bennu as a single pixel moving across a field of stars. Over the following months, Bennu grew from a pixel into a world, with OSIRIS-REX revealing its shape, rotation, and color for the first time. Now, after chasing its target for over 2 years, OSIRIS-REX is arriving at asteroid Bennu. On December 3rd, it will fire its thrusters to match Bennu's velocity and begin its preliminary survey. OSIRIS-REX will pass high above the equator and the poles, measuring Bennu's position and mass, and refining its size, shape, and spin. On New Year's Eve, OSIRIS-REX will venture close enough to Bennu to be captured into orbit by its minuscule gravity, making it the smallest world ever to be orbited by a spacecraft. In early 2019, OSIRIS-REX will break orbit to conduct a detailed survey of Bennu. First, it will carry out a mapping campaign called the Baseball Diamond. By observing Bennu at different latitudes and times of day, OSIRIS-REX will capture stereo images and identify large rocks on the surface that could pose a hazard later in the mission. In its second mapping campaign, OSIRIS-REX will observe Bennu from 7 different stations around its equator. At each station, it will take measurements from pole to pole using its mapping camera, laser altimeter, and 2 spectrometers. The combined data will provide a detailed look at Bennu's geologic features and its composition. This will improve landmark-based navigation and enable mission planners to begin looking for places to collect a sample. Following the detailed survey, OSIRIS-REX will once again enter orbit. At a radius of only 1 kilometer, Orbital B will serve as the mission's safe home orbit until sample collection. During this phase, OSIRIS-REX will globally map Bennu. It will fly in a polar orbit as the asteroid rotates beneath, enabling full coverage of the surface. Orbital B's precession, or wobble, will also be used to measure Bennu's gravity field, along with the non-gravitational forces that are slowly altering Bennu's trajectory. In mid-2019, OSIRIS-REX will begin its reconnaissance phase. It will break orbit and fly over 4 candidate sample sites at 225 meters, taking high-resolution images. Flying at such close proximity will reveal large pebbles that could pose a hazard during sample collection. Mission planners will use this information to select the 2 best sites for additional inspection. At a range of 525 meters, OSIRIS-REX will fly over the 2 final candidate sites, spectrally mapping the surface to reveal its chemical composition. This information will help mission planners determine the most valuable site for collecting the sample. Once the final site has been selected, OSIRIS-REX will begin its rehearsal phase. First, it will practice autonomous flight to a predetermined checkpoint, where it will start its descent during sample collection. Next, OSIRIS-REX will practice flying to the match point. The spacecraft will lower to within 30 meters of the surface to match Bennu's speed and rotation, a necessity for safely touching the asteroid. Finally, in mid-2020, OSIRIS-REX will be ready to collect a sample of Bennu. Before it descends to the surface, the spacecraft will deploy its touch-and-go sample acquisition mechanism, or TAG-SAM, a new technology invented for the mission. When it reaches the checkpoint, OSIRIS-REX will begin its final descent. It will pull back its solar arrays for safety and approach the surface at centimeters per second, the walking pace of an insect. As the TAG-SAM touches down, it will blow high-pressure nitrogen gas into the soil, stirring up loose material. A filter within the sample head will trap rocks and dirt while allowing the gas to escape to space. Once the sample is collected, OSIRIS-REX will fire its thrusters and back away from Bennu, retreating to a safe distance with its precious cargo. Following collection, OSIRIS-REX will verify the status of the sample using a camera called SAMCAM. This visual inspection will reveal whether any large debris is still attached to the sample head, which could pose a hazard during stowage. Next, OSIRIS-REX will verify the mass of the sample. It will fully extend its TAG-SAM arm and perform a spin maneuver, measuring the change in inertia to determine the sample's mass. If at least 60 grams have been collected and the sample head is clear of hazardous debris, mission planners will command the spacecraft to stow the sample. STOWCAM will watch closely as the sample head enters the return capsule and is secured in place. OSIRIS-REX will then detach the TAG-SAM arm from the head, seal the sample return capsule, and prepare for its journey back to Earth. After departing from Bennu in early 2021, OSIRIS-REX will return to Earth in late 2023. 4 hours prior to arrival, the spacecraft will release the sample return capsule, then deflect away from Earth to its final orbit as its piece of Bennu comes home. The capsule will enter the atmosphere over the night side of Earth, streaking towards the central California coastline at over 12 kilometers per second. West of the Great Salt Lake, at an altitude of approximately 33 kilometers, the capsule will initiate its parachute sequence, stabilizing and slowing its descent. Upon landing in the Utah desert, the sample will be recovered, carefully removed from the capsule, and taken to the OSIRIS-REX curation facility at NASA's Johnson Space Center in Houston, Texas. This pristine material from the early solar system will be studied for decades to come, providing clues to the formation of the planets, to the evolution of Earth, and to the ingredients that were present at the origins of life.
Of Bennu as OSIRIS-REX comes up. So what are we looking at in this video?
So during our approach, we've been slowly creeping up to Bennu, and During that time, we've been taking the opportunity to snap images using the OCAM's camera suite that was built at the University of Arizona. So we've had a very active campaign imaging Bennu as we're approaching the surface. And it's given us an opportunity to really get a sneak peek at what we're about to embark on. So we're getting great images back. We can see the surface has got a lot of boulders, craters, a lot of diversity in the surface. So it's been really exciting.
Stand by for Bennu arrival. So you can see here we have the Doppler residual, so we know the burn is occurring because I'm seeing a change in velocity from the spacecraft.
It's got very quiet here. Everyone's just going.
We have arrived.
You may have noticed we were doing a bit of an unusual high five there. That's called the tag five, because that's reminiscent of the tag SAM arm that's eventually going to retrieve a sample.
Well, as of 2015, the plan wasn't to go out and capture the whole space rock, but just a small piece of it, because it turns out asteroids can get kind of big. It's hard to capture something that might be half a kilometer. Picking up a multi-ton boulder off of a larger asteroid was much easier, and we could then bring it back and inspect it just like we were planning with the big one. And you would also still keep it in the orbit of the moon. NASA's arm came after cancellation of the Constellation mission back in 2010. Constellation was over budget, it was behind schedule, and President Obama canceled it. Thanks, Obama. In case you aren't familiar, Constellation was the NASA program that wanted to put people on Mars. But later in 2010, Obama issued a directive to NASA to get astronauts to a near-Earth asteroid by 2025, and then to Mars by the mid-2030s. A study came out a little after that from the Keck Institute of Space Sciences at Caltech in Pasadena. And the study looked at the feasibility of sending a robotic spacecraft to capture a small asteroid, like 7 meters wide, then tow it back to lunar orbit. They concluded that it could be done for about $2.6 billion. Not bad. It's like a couple days of government spending. NASA took notice of the paper, they did their own study, and in April of 2013 unveiled the Asteroid Redirect mission.
Projected to come close to Earth later this year has a 0.41% chance of hitting the planet, according to NASA data. The Center for Near-Earth Object Studies, CNEOS, from NASA's Jet Propulsion Laboratory, said the celestial object, known as 2018 VP1, is predicted to pass near Earth one day before the U.S. presidential election on 2 November. The space agency said there were 3 potential impacts, but, based on 21 observations spanning 12.968 days, it did not think a direct impact was likely. 2018 VP1, which was first identified at Palomar Observatory, California, in 2018, is not considered a potentially hazardous object due to its small size, with a diameter of 0.002 kilometers, about 6.5 feet, according to NASA data. Potentially hazardous objects, usually asteroids or comets, are those which have an orbit taking them close to Earth and are large enough to cause significant regional damage if they ever hit the planet. Earlier this week, an asteroid flew just 1,830 miles over the southern Indian Ocean, the closest such an object has flown past Earth on record. The object, known as Asteroid 2020 GC, was spotted by the Zwicky Transient Facility, a robotic camera which scans the sky, and is thought to be roughly the size of a large car. Its small size meant Asteroid 2020 GC did not pose much of a threat to Earth, as it would have likely broken up in the planet's atmosphere if it was on course for direct impact. It's really cool to see a small asteroid come by this close, because we can see the Earth's gravity dramatically bend its trajectory, Paul Chodas, director of CNEOS, said of the discovery. Our calculations show that this asteroid got turned by 45 degrees or so as it swung by our planet.
Alright YouTubers, this is the Angry Prepper. So today's video is going to be a quick heads up video on an asteroid that's headed towards planet Earth. Now the asteroid is designated to 2018 VP1. This has been tracked since 2018, hence the designation. It was discovered back in 2018. I don't know what scientists, discovered it, but nonetheless they've been tracking it, and now that it's 2020, 2 years later, they think it's going to hit the planet. Now, they think it's going to hit the planet with a less than 1% probability. But the alarming thing in the article I read was that it had 3 impact areas. That was a red flag for me. That was something to be a little concerned about. So, with that being said, keep prepping. Keep putting food away. Don't stop. Don't panic. Panicking is your enemy. Just know that this asteroid is 6.5 miles long. If it does hit us, it's most likely to hit water because this planet's more water than it is land. And if it hits land, the probability of a, nuclear winter, if you will, could happen. And what that means is enough dust can get kicked up into the atmosphere to cool the planet off to put us in a mini ice age. Again, that's not the end of the world. It just means we're going to have a shittier winter, right? And a shittier crop season as well. So, with that being said, guys, this is just a heads up video. That's all it is. And it should be arriving, either missing us or hitting around November. This is just something that's been put on my radar. Like I said, it's been put on my radar months ago. Actually, almost last year. I found out about it, but I sort of discarded it because they weren't sure. Now that their mainstream media is starting to report it a little more, it's something to keep your eyes on. That's it. Again, it is not to panic. We don't panic. We don't panic till the last minute. And even then, you don't panic. That being said, just keep your eyes on this asteroid. The asteroid is 2018 VP1. That's its designation. You can follow it if I'm not mistaken. You can go online and I think there's some observatories that are tracking it. So just track it and don't panic. That's it. If it's going to hit your city, evacuate. If it's going to hit close by, evacuate. If it's not going to hit anywhere near you, don't worry about it. So this asteroid was brought to the attention of a few YouTubers. One guy, his name Israel something, or Israelite something another. Can't remember his name. But anyway, he was talking about it earlier this year and last year. And I listened to his channel, but then I disregarded it. Not because it was going to happen, but because I had to wait till it got closer. Well, now it's closer. Now it looks like it hitting us is a probability, right? And whereas before, a lot of the asteroids that passed us by a few thousand miles, a few million miles actually, right? So that's good. If this passes us, this is going to pass us pretty close. But there was another asteroid that passed us pretty close a couple weeks ago. And I don't think scientists knew about it until it passed, if I'm not mistaken. Nonetheless, it seems like we're a shooting gallery now. And what way to end a year, a shitty year, than a possible asteroid strike. Anyway, guys, this is just a heads up video. That's all it is. It's pretty short. Other than that, guys, this is the Angry Prepper. You can like and subscribe to this channel. You can follow me on Instagram, Facebook, Tumblr, and Twitter. And other than that, guys, thank you for watching.